Given an ellipse with a major axis of 10 and foci at 5, 2 and negative 1, 2, write an equation. Okay? So what I want to do is I'm going to come over here to a graph grid, take this information and kind of sketch out what we're looking at and then write the equation. Okay? So here's our graph grid. And we were told that our foci were at 5, 2 and negative 1, 2. And I like to put an F. Those are my foci, or focal points. Now what that tells me is that my major axis that has to be my major axis. Okay? This has to be my major axis here. Okay? This has to be my major axis. Why? Because the foci have to be on the major axis and they're horizontal points. They're horizontally spaced from each other. Okay? So if my major axis has to be in this direction, we were told it has a length of 10. So what I want you to do is realize that the center has to be exactly between these foci. So this is 1, 2, 3, 4, 5, 6. These foci have a distance between them of 6. So 1, 2, 3, right, half of 6, that has to be the center. That has to be the center. Well, if the major axis has a length of 10, the semi-major axis, which will go from the center to the edge, has to have a length of 5. So 1, 2, 3, 4, 5. There's one edge, and then we go 1, 2, 3, 4, 5. There's the other edge. So our ellipse is going to go somewhere like that. Okay? So now, what do we know? We know A equals 5. We know C equals 3. Right? Because from here to here is defined as A. From here to here is defined as A. And from here to here is the length C, which is the focal axis. Okay? And that's just our center here. Okay? So we know A is 5, we know C is 3, and we know the center is at 2, 2. 2, 2. So it's been moved up 2, and it's been moved to the right 2. Okay? So now, if we move our paper around some more, we want to write this equation. So I know A equals 5, C equals 3, and the center is at 2, 2. Okay? So I have an equation for an ellipse. It says C squared equals A squared minus B squared. Okay? So this is 9. This is 25. And so we can solve for B squared. And when we do that, we get B squared equals 16. Alright, so we're going to hang on to that. Now, let's write the equation. Given this information, let's write the equation. What's the equation look like? X minus H. Well, that's going to be minus 2 over A squared plus Y minus K, right? This is H and this is K over B squared equals 1. And there's our equation for our ellipse. So I think it's useful to sketch this out. You don't have to, but it lets you see that the major axis is in fact horizontal, which means the larger number will be under X. Okay? So let's do an application. It says a semi-elliptical archway has a height in the center of 30 feet and at its widest point is 18 feet wide. How wide is the arch 10 feet off the ground? So I'm going to draw a picture of this, okay, to kind of give us an idea what this looks like. So here's the ground, and here's this semi-elliptical arch. Now what that means is it's half of an ellipse. Okay, so the other half would be underground. Okay, so you have to picture the other half of this would be underground. Okay, and that says it has a height. So here's the center. Okay, here's the center. It says it has a height of 30 feet. And a width of, from here to here, 18 feet. But I'm not going to draw that. I'm going to go from here to here and call it 9 feet. And so now what you've just done is you've said this is A and this is B. Okay, this is A, this is B. And the center can be anywhere you want because this is a real life problem. And I'm going to say it's at 0, 0. So what I have is I have A and I have B and I have H and I have K. And I can write an equation. Okay? So here's the equation. It is X minus 0, right, squared, over B squared, plus Y minus K, which is 0, squared, over A squared, equals 1. Okay? There's the equation of this ellipse. Okay? So then it says, how wide is the arch? Okay? Let's go back to the question. How wide is the arch? Now, if we think of width, that's in this direction here. So that's asking what? For some X value, when the arch is 10 feet off the ground, which is what? Y equals 10. Okay? So we go back to our equation, and what are they telling us? They're telling us to plug in Y equals 10. So we take this equation, and we say X squared over 81 plus 10 squared over 900 equals 1. Well, 10 squared is 100. So this whole fraction just becomes 1 over 9. So X squared over 81. Okay? So we subtract this from 1. We get X squared over 81 equals 8/9, right? Because 1 minus 1/9 gives us 8/9. Then I'm going to multiply this fraction by 81. Okay? And I get, I'm going to run out of paper here. I get X squared equals 648 over 9. And then we're going to take the square root of both sides. Okay? And we do that, we get X equals. Now, normally we would say plus or minus because we're taking a square root. And I am in fact going to write that because if you go back to your, so let me put my plus minus. If you go back to your picture, right, we're some 10 feet off the ground, one X value will be to the right and one X value will be to the left. So it is a plus minus. And what we're actually going to do is take that distance plus that distance, or that distance times 2. Okay? So X equals plus or minus. And I know the square root of 9 off the top of my head is 3. The square root of 648 having trouble with my calculator. It's not wanting to work for me today. Okay, it's going to give me some really crazy decimal. So square root 648 over 3. And so if this comes out to a pretty number, or if you're wanting an exact value, it'll be something like this, or we'll try and reduce this radical. But I'm going to go ahead and take that decimal, that root 648, and divide it by 3. And I get x equals plus or minus 8.485, and there's more, but we'll stop there. Okay, so what are we saying? Again, going back to our picture, okay, we're saying that this distance here, for all intensive purposes, is 8.5 feet. Okay, so if that's 8.5, that's 8.5. We can double that and get basically 17. So we'll say the width at 10 feet off the ground is 17 feet. And of course, if they wanted you to round this to 1 decimal place or something like that, you know how to round. We're not worried about that. The concept is what's important. Okay, so that is an application with an ellipse, elliptical tunnels and things like that. So if you have questions, let me know.